We are the latency panel, so we're allowed to be a little bit late. That's okay. That's cool. Well, we've got some great guests. I hope you guys have enjoyed the morning so far. Been some brilliant, engaging discussions going on in both rooms. And we've got the before lunch session, so we'll try to keep it on time because I know you'll get hungry and, you know. So my name's Dom Robinson. You probably know me better as one of the writers for Streamer Media Magazine. I've been writing for the guys since 2002, so a little long in the tooth now. And Eric's been herding me towards writing more future-thinking stuff as my own software company started to creep up the stack and deliver stuff right across the spectrum. It's a bit unethical to review my competitors all the time, but I've been around a while. We specialize in virtualized software. We've been doing it for about a decade. We do everything from video compression and orchestrated distribution networks and so on and so forth. So if you want to come and talk to me a bit about that afterwards, then do. If you want to know more about CDNs, I must plug my book, Content Delivery Networks book. You have to do the plug while you're here, of course. I learned from the master. And I also, some of you may know me from chairing the Content Delivery World conference, which is sort of 6 months out of sync with this one over in the UK and so on. So excuse the plummy accent. I say router, you say router. We'll do it differently. With no more to do, let me let my panelists introduce themselves because these guys are the guys you're here to hear from. So Ryan, can I ask you to kick off?
I'm Ryan Durfey. I am the Comcast CDN Senior Product Manager.
I'm Damien Lucas. I'm CTO and co-founder of Anevia.
I'm Eric Klein, Director of Infrastructure Delivery at BAMTECH Media.
Hi everyone, Igor Oreper. I head up the solutions team for Bitmovin.
Cool, excellent. So we're here to talk about the topic of the day. If 2017 was the year of virtualization, 2018 is the year of latency for sure. It's a topic on everyone's mind. Everyone's putting it into every presentation, or most presentations this morning so far. And latency is a big issue. We were talking on a live podcast that I run with Eric and a couple of the other writers the other day about the different motivators for latency. And it is interesting crossing the Atlantic. Over here, latency is very much about sports, that apocryphal story of the goal. You hear your broadcast fans listening to the goal a few seconds before you see the feed and trying to beat Twitter and so on. So latency is very important this side of the water for that reason. The other side of the water, it's very important for betting, which is obviously a different market over here, and they drive the market in different ways. But what I wanted to do is, first of all, kick off a little bit with a discussion about how you guys are delivering your services and where latency gets introduced in those services. So, Ryan, can I start? I'm going to sweep left to right each time. So, Ryan, can I start with you on that question? How are you delivering your services today, and where do you find latencies getting introduced?
So we deliver a ton of our own video over our own CDN, and part of our solution was driving, and some of the earlier presenters talked about pushing the CDN down into the provider network. And that's really what we've done for ourselves as to overcome latency. Where if you look at most pure play CDNs, they're going to be in the kind of the core data centers where everybody's peering. We are pushing our network out into our last mile facilities. Where a pure play CDN might have 15 pops, we have 150 pops. And we've done that specifically to address that level of quality and that latency between the CDN server and the last mile user.
Cool. And Damien, you obviously provide technologies and so on. So where are you seeing latency introduced within the networks?
Yeah, so in fact, what we provide is basically the encoders, origin packager, and some cache servers. And we always try to understand from a glass-to-glass point of view where the latency comes. Encoding, obviously, is probably number one. Packaging comes number two with the different formats that we can find, and reducing the latency on the packager side is probably the point where we can do the best savings. And I'd like to mention the new CMAF format that enables very low latency that basically help us to get below 1 second latency end-to-end for those different functions: encoder, origin packager, and cache servers together.
Excellent. All right.
Yeah, and just to follow up with what Damien was saying, again, we kind of have the whole workflow, the encoding, the packaging, the delivery, the caching, that all add different steps to the latency. CMAP's actually something that quite a lot of our members of our team are active in and looking at, so it's certainly something that's on our radar quite a bit. But from a delivery standpoint, the area I kind of focus in, the latency itself is something that's inherent in the fact that we're using multiple different content delivery networks for delivery to handle the capacity and the load. It's something we deal with and are aware of. And so it kind of shapes the presentation and how we choose to work with our content. It's kind of to your point, Dom, the beat the Twitter effect, right? The goal is to beat the Twitter response to things today, and obviously continue to work to improve that latency with our CDN partners, with our encoding stack, and with the different formats that we use for delivery.
Igor.
Yeah, so Bitmovin is a services provider. We focus on encoding and playback, so we kind of straddle the content delivery, if you will, on both sides. And so when I think about our customers, they're interested in how long does it take to encode live video. And for us, encoding is actually inclusive of packaging, right? So to Damien's point, latency is introduced when you're encoding the content, when you're packaging the content. There's additional latency depending on what CDN you're using and how it's configured. And then there's also latency on playback, right? How long does it take for your player to start up? How is your player doing, adaptive rate control? How is it figuring out, how much bandwidth is available for a given client? So latency is going to vary on a client-by-client basis, not just because of how you're encoding and processing things server-side, but also how each client, what playback client they're actually using, what device it's running on. So there's a lot of different variables, and I think that causes different latency or broadcast delay for different user sets. So there's a ton of different variables.
Okay, so let's go down the stack a little bit, because obviously this is a CDN, content delivery network focused audience, but let's go down the stack a little bit, because some CDNs will deal with the encoding internally, some won't, and so on. So Ryan, in Comcast case, are you doing much transcoding, encoding internally in the network? Are you expecting your publishers and your upstream providers to do that work?
We span the gamut there. We definitely provide transcoding and encoding services, but we also have a ton of customers that do it themselves.
Mm-hmm. And so, Damien, you mentioned CMAF and so on. When you start moving into the video encoding space and looking in detail at video encoding, what are the tips and tricks that guys in the audience can take on board to optimize and to reduce that latency in the encoding space, not in the transmission and so on, but just in the encoding space?
Yeah, I think it's very important to understand that encoding is a key part of this delivery, especially when you want to improve the latency, decrease the latency. And that's the reason why Anevia has been focused on the delivery side for years now. And it's only a few months that we have acquired a company that was specifically acting in the compression. Because we think that in the current era, and for now on, this year's main topic being latency, it's very important to include the encoding as part of our offering. And especially with the new formats coming in, et cetera, that is very important. So with these products that we have from this acquisition, the company name was Pixo, we have a software-based encoder that is able to do few hundred milliseconds for encoding at a very high quality and very low rate, H.264 or HEVC. And the codec doesn't matter that much. What really matters is having a software encoder, because this is a way to actually achieve the latest latency we can have.
Okay, and Eric, and in your case, you obviously do a lot of content encoding and so on. What are the methods and approaches you take to reduce that latency just in the encoding stage for the moment?
So there's a specific team that's actually working and managing coding on that, but there's a consideration for delivery from the actual encode all the way on down. So that's everything from the stack choices that we make and how we choose what specific bit rates we're using and where and why, all the way down to how the package is actually being created when we prepare it for delivery. You know, what segment size are we going to use? What methodology are we going to ultimately deliver the content through? All these things are kind of coming into play as part of that initial encoding decision-making process, and then funnels down to the delivery team that I kind of work with.
Okay, and so Eric's mentioned there the quality question when it comes down to video encoding. Igor, would you have any advice for the audience here about, I mean, obviously you can reduce quality infinitely to reduce your latency. You know, we can all watch a very, very poor 1996 2 centimeter square video stream, extremely low latency. You know, what advice would you give in drawing those boundaries and drawing those lines?
So there's definitely a lot of optimization I think we all are at this point aware of, you know, with segment size, with GOPS, with, you know, how much are you keeping in a buffer before you start distributing out to your CDN and to your end users. So Twitter actually has a really good blog post about this, the Periscope blog. I don't know if you guys have seen this, but it's about low latency HLS. And so Twitter uses the Bitmovin player for Periscope. And so what we did is we worked really closely with Twitter to you know, really get to their goal, which was 2 to 3 second end-to-end broadcast delay. They actually beat that goal by about 2 seconds, so they're sub-second broadcast delay for Periscope feeds right now, which is really neat. And it's a good example of how you can optimize the server side using low latency HLS approach and also, you know, tweak your player in a way that you're keeping a really low buffer, but it's very, very fast. So I encourage you all to read the blog post. I'm going to just summarize it. But basically, low latency HLS uses chunk transfer encoding, which is an HTTP 1.1 spec. And there's some improvements to that with HTTP 2, which they're experimenting with. And I know a lot of other folks are as well. But basically, you're sending a constant stream of bytes to the client before they actually become available. And then you're using a really good origin shield cache to keep the, you know, the flood of requests that are coming from the clients from actually hitting your origin. And so you're basically blocking those requests until the content becomes available. And so, you know, the traditional delivery method is, right, you encode a chunk of video, you put it up on the origin, you tell all your clients, hey, it's available, come get it. In this approach, you're just telling the clients, hey, just keep asking me for the next chunk, and when it's available, it's available. And so, you know, this method, which they call low latency HLS, works really well. Encourage you all to read the blog, but that's one of what I think is a more innovative but also very practical way to decrease broadcast delay that at least I've seen in the past year.
You mentioned HLS. That was a perfect segue into the next notch down. Let's look at packaging now. So, HLS, it's obviously it's a sort of work in progress at some level. It's exploded the market on one side. You know, I think we've seen a huge video adoption in the last couple of years since HLS has become kind of the go-to way forward and so on. But it has inherent issues with latency. You need to wait for a few segments to come through before you can start rendering, before you can start using the video. Are there any other tips and tricks that you guys have collectively, separately in the packaging layer to reduce that latency, to get that video running sooner and faster? Ryan, any thoughts on that space?
I think one of the things that we see with a lot of providers is just trying to do a bit too much. You can reproduce, you know, 14 different bit rates and try to, you know, squeeze into all these different layers for different devices. And caching at the edge is a popularity contest. So to get your content out there at the edge, you've got to be cognizant of the fact that your library can't get too large. If you can focus down to the key bit rates that are going to make a difference to your end users, I think that's one thing that keeps your content out at the edge and keeps it popular and stuck where it can be accessed very quickly.
Damien, any thoughts on packaging?
Well, basically, I think that all the different formats have evolved in order to have, let's say, variation that enables low latency, whether that's HLS, as you mentioned, CMAF with the LLC part of CMAF. I mean, this is achievable with all the different formats, whether that's standard or not yet fully standard, it will be standard soon. So the question is not exactly a question of standard, but I'll be back to the point where we have a number of different streams, and the target is to be able to have the same very low latency on all different devices. Otherwise, it makes no point. If you end up with an Android device being 2 seconds after the Apple device and 5 seconds after a Microsoft device, it makes no sense. So the packager needs to have a common latency approach, whatever the protocol is, and having a right just-in-time packaging, low latency packager, that would be the key to the success, to address all different formats for all different devices with the same low latency target.
Eric, any thoughts on packaging?
So we actually have Bill May, who works at BAMTECH, who's one of the contributors to the HLS spec. And one of the things that we've tried to continue to do as part of our engagement in reducing latency is looking at ways that we can borrow quite a lot from the HLS spec that we do quite a lot of delivery through, but also look at CMAF and what's coming next, and how we can bridge the two. And so fragmented MP4s that are becoming more and more standard as CMAF kind of progresses, looking ways that we can leverage that with our existing HLS setup to potentially take advantage of things like range requests. Start at the edge and begin to make those range requests earlier for the content. Similar to what Igor was talking about before with low latency HLS, make those range requests potentially before the content's even complete, but you can get the content out to your end user quicker while still maintaining that consistent packaging across the board and meet, to Ryan's point, popularity on the CDN.
Yeah. Igor, any thoughts on packaging?
Yeah, so I guess I kind of answered that with the
Yeah.
last
Yeah.
question.
You segued us, you cheated yourself out of the question.
Yeah, I mean, I would say to add to low latency HLS and to Damien's point, I think you want to get to some sort of common format across devices. I think CMAF is a really great step in that direction. It's not yet widely adopted. More and more encoding and packaging providers are supporting fragmented MP4s, and I'm optimistic that that's a good direction to go.
Okay, let's go down one more notch. Let's go down into well, transport. I don't know if transport's a good broad brush to describe things, but looking at HTTP, these guys are going to be largely running HTTP forwarding, caches, and so on and so forth. Obviously, there's a lot of people, we've done some projects recently ourselves with WebRTC. WebRTC is rearing its head, session-based protocols. A lot of the problems that we face today were solved with session-based protocols 10, 15 years ago and then put to one side because of the popularity of HTTP. We've got a kind of VHS and Betamax moment going on. But given we've got to be pragmatic and deal with HTTP, or maybe we don't, other CDNs able to offer, or are you, as in Comcast case and BAMTECH's case, are you able to mix and match, or are you now dominantly stuck with HTTP? Is HTTP absolutely a foregone conclusion?
I think HTTP is the ubiquitous standard these days. We obviously support 1.1. We're about to release HTTP 2. There's also a push to support quick-based delivery. We've definitely seen the advent of a lot of sort of proprietary protocols, UDP-based, but they just haven't really taken off. I think WebRTC is probably the next one that sort of steps in and fills that gap if it can, be modified slightly to address certain concerns.
Damien.
Yeah, I think we need to remind why we've moved to HTTP, because the session-based protocol, they were perfect for a lot of different reasons, and I still see a lot of operators that want to keep those session-based protocol, RTSP, RTMP, or whatever, because It's easier to track session, it's way better in terms of latency and so on and so on. But it's very limited to a managed network. And this is the key. So HTTP is really required in order to have OTT. Otherwise, you're just stuck to the managed network. So once we've said that, I mean, we are fundamentally at Anevia pushing for HTTP-based protocol and only HTTP-based protocol. Whether that's HTTP, HTTP 1.1, HTTP 2, I would put Quick in the same HTTP family. That's definitely for sure.
Yeah, I think HTTP from an edge delivery standpoint, getting out to the consumers is still the de facto standard, and I can foresee it being that for a long time. It's the ubiquity of it, right? It's easy, it's simple, it enables us to hit quite a lot of devices without having to make any changes to clients. And to Ryan's point, there's a lot of proprietary protocols out there that you can play with, but at the end of the day, HTTP is standard and it works. Each client might do a little bit different behavior with HTTP and might be leveraging HTTP 2 benefits or HTTP 1.1, but it's still fundamentally the same protocol. The one area I think it's interesting to potentially look at alternative protocols is more on the ingest side of things, where we grab content and acquire content. It's an area that can be more proprietary because you own that stack end to end for the most part, and you can reduce latency within your workflow on that element of it so that you can still maintain the ubiquity down to the millions of users that you need to reach for OTT on the edge through HTTP.
Igor.
Yeah, so RTMP was a thing, and for distribution, it's still a thing for ingest, although that's changing to Eric's point. But it's expensive, right? You need a lot of infrastructure to support RTMP streaming. It's all unicast. There's no caching, right? It's super expensive, and so everyone went to HTTP because you can distribute it horizontally as much as you want. But there's still limitations there in HTTP 1.1 with the way that socket control works. With HTTP 2, that gets much better, and you get much better performance, and you need less infrastructure to maintain open connections to your edge caches with HTTP 2. So I think that I think is going to be a bigger, more material change than peer-to-peer networking, although I do think peer-to-peer networking does have its really great use cases, right? Rural, remote areas where there isn't a lot of network infrastructure, but there are people, right? There are peers who can, some with good throughput and connection who can then help to distribute content to their peers. So I think in my sort of understanding, the move to HTTP 2 as more CDNs adopt HTTP 2, that what we now think of as traditional video delivery over the internet can scale even better, but then it's augmented by peer-to-peer networks, caching networks, and there are a handful of those out there that work really well today. And then on ingest, to Eric's point, I think that's a really good point. If you're doing live streaming today, whether it's event-based or it's linear 24/7 feeds, there's a real challenge right now in acquiring all of those feeds in an efficient way, ideally over the internet. Very little of that ingest and acquisition happens over the internet today, but it's growing. And I think that if you focus on end-to-end, latency and broadcast delay, focus on ingest too, right? Don't just think about, well, how long does it take after you get the content and you start processing it to deliver to end users.
On the subject of RTMP, we've often joked that over the last few years that yet again there's going to be another article that's going to be, that one of us will write, that'll come out saying RTMP is dead. It just seems to happen every couple of years. We need to write that article again, but it's just not going away. Although, SRT is interesting. Have a little think. I'm going to ask the guys one more question, but then I'm going to come to you guys for questions. So get your questions ready. So in an environment where you're starting to use multiple CDNs, and which more and more publishers and content providers are doing, What are the challenges there? What, does that introduce more? Does the CDN brokers, the Convivas, the Sodexas of the world, do they help? Do they actually add latency? Are there any challenges that are introduced when you try to go to a multi-CDN strategy?
You mentioned the providers. I think that they all add value. I think that each provider is sort of narrowly is best used for a specific use case. You've got download measurements. Those are your folks like Sodexis and Dyn. I think those match really well with folks that are doing software downloads, website delivery. I think the key there is measuring your own downloads and making sure that you're getting your performance to your end users. I think there are some great video providers in the space. Deliver is a new entry to the marketplace in the last few years. I think they're a great entry level for folks that want to dip a toe in the water and can't face the integration costs or the high cost to move into that CDN, multi-CDN space. And then you've got the folks like Conviva, Nice People at Work, Mux, and I think those guys, that client side or player side integration is great for folks that are maturing and really want to hit that high mark of broadcast availability.
Perfect. Damien, any thoughts on multi-CDN strategies or deploying your infrastructure across multiple environments?
As maybe Igor said before, and as Ryan said as well, we see that in order to cope with the traffic, in order to deliver the best quality, we need other tools in order to boost the CDN. That can be peer-to-peer, that can be multiple CDN, it could be multicast ABR. There are a number of different available tools to boost the CDN capabilities. But the common point between all those tools is that they all add a bit of latency. So it's very important to try to reduce the latency at the beginning from the ingest part, from the encoding, packaging, so that we can reach these end-to-end, maybe 2, 3, 4 seconds, beating Twitter, which is a point, being not after the broadcast live, I mean traditional broadcast live, cable TV or whatever. So the target is end-to-end within 2, 3, maybe 4 seconds. So if you have some additional tools such as multicast ABR, peer-to-peer, multi-CDN that adds 1 second for some of them, then it means you've got a second less from these ingest, encoder, packaging, and first shield or first cache servers. And that's really the point. I mean, we need to keep in mind the target, and there are very specific applications that may need sub-second latency, what we call ultra-low latency. I think of military video encoding and some others. But most of the time, the question is fitting the whole process within 2 to 3 seconds, from glass to glass.
Mm-hmm. Eric, any thoughts to add on multi-infrastructure environments?
Yeah, I mean, for the most part, I live in a multi-CDN world. That's how we manage content delivery for quite a lot of our partners and for the scale that we need to reach. And it's all about, in that specific world, managing those partners so that you have consistency of performance. And so latency is an important factor that you consider, but at the end of the day, if a user is watching a stream and they're engaged in a stream, you want to ensure that their performance is consistent throughout. And so it goes to Ryan's point about considering different factors and tooling out there, really looking at both quality of service and the quality of the actual delivery of the byte, as well as the quality of the experience and leveraging things like Conviva to look at what the actual client is performing as. Mm-hmm. And if you can take in both of those factors, you kind of start to get a sense of which CDNs perform better for certain delivery metrics and which perform better for other regions or locations, and managing the expectations and the need to reach customers in different regions. We've done things where we've been a bit more hands-on in terms of some of the choices that we make from a delivery standpoint, but we do so strategically. We do so from a consistency standpoint for mass scale of users, let's say in North America, but then we make different decisions in different parts of the world in terms of splitting up our content. And the goal there is ultimately to remove that decision-making process, at least somewhat, from the delivery chain so that we don't add additional latency to the requests that the user is experiencing.
Igor, any thoughts on multi-infrastructure?
Yeah, so I mean, I think multi-CDN delivery at this point is just a given, right? I mean, almost everyone is doing it, and if you're not, there's probably very good reasons why not. Given that, I think the next step is how do you think about playback? How do you make sure that your clients are aware of the CDNs that are delivering and the content and the pros and cons of each of those CDNs, right? How do you dynamically adjust the way that your client will buffer and playback video based on the configuration of a given CDN, which may be selected in real time by one of these CDN arbitrage tools. So I think that's the next step in further optimizing delivery and making it more consistent across your client base is making your clients more aware of what CDN is delivering that traffic and adjusting the settings and configuration of your client in real time to support it.
Right, so if this was a live transmission, we'd be hitting the moment of ending the transmission bang on, and it would be lunchtime. But we're going to delay it for just a second because we should take a question, politely take a question from the floor. So first hand in the air will get the question. Any questions from the floor? There we go. We got one in the middle.
This is mainly for Eric. I'm just wondering about, you look at the glass proposal, you guys have talked mostly about ingest on. What about pre-ingest? Are you given typically transport streams so you don't have any control over the latency before that, say, in the origin encode of the mezzanine stream? And how does that latency compare to the transcode latency?
So just to repeat the question, it's asking about prior to ingest, the ability for us to receive the actual source stream itself. Is that fair? So there's a different team that kind of manages that, but the way we traditionally grab things are both off satellite and sometimes direct source feeds. It really would depend on the different acquisition feed that we would have for a specific event or partner. And in those scenarios, what I tend to find is that it's traditionally the same source feed they might be providing to a cable provider, right? So you're inherently facing latency from the get-go. And so the goal on our side then is things like different protocols that we might be able to do to improve the latency that might occur post-ingest before encoding and packaging for delivery. So it's really the things we might need to do upstream on our side to take advantage of it, not necessarily things we do today from our content sources providing us the content.
Okay, any last tips from the panel in response to that question?
Yeah, I think we're back to the question of what do we compare? And I perfectly agree with Eric. At the point is we compare with traditional cable live TV. We compare with Twitter feeds, and people tweet based on cable live TV, or sometimes being really in the place of the event. So the point is, as long as the different broadcast technologies, OTT or cable live, are sharing the same input stream, it doesn't really matter whether you got an SDI direct feed or you're getting the feed through satellite. The point is making sure that we can align everything, aligning broadcast cable live, aligning different formats for different devices. The whole point is there.
Cool, brilliant. Well, look, for those of you watching live on WebRTC, the session's over. And now it's over on HLS. Thank you very much. It's lunchtime. See you later.
We will have a lunch presentation probably in about 15 minutes, so that'll give you some time to grab your box lunch, come in, get a seat, and sort of settle down. We'll see everybody in just a little bit.